Okay, students, this is Mod 2, Topic 1, Lesson 2. Our key terms right here, and I'll tell you which ones to add to your vocab. We're going to make conjectures about the diagonals of special quadrilaterals. This whole unit, you're going to be using your quadrilateral hierarchy. You need to learn it about the characteristics now. But have out that sheet as well so you can follow along with the quadrilateral hierarchy. Okay. We're going to make conjectures about the angle relationships of special quadrilaterals called inscribed quadrilaterals. Here they're called cyclic quadrilaterals. Never heard of that term before. Every other book is called inscribed quadrilateral. So just know that. We're going to categorize your quadrilaterals like we've been doing based on their properties now. And understand that the vertices of the inscribed quadrilateral are on the circle, just like an inscribed angle. All right, go ahead and try to identify these figures with as many names as possible. So remember, before we asked for the most specific name. So that would be name the most specific name, but all the ones above it that it fits as well. That's what it means to use as many names as possible. So go ahead and do those three, compare with your neighbor, and then we'll go on from there. All right, next page. Consider two quadrilaterals shown. A quadrilateral has exactly two diagonals. Remember, a diagonal, let's draw one here. So we gotta come back to the pen. Remember, a diagonal connects one vertex to another vertex that it's not already connected to. So it's the non-adjacent ones. Okay, there's that one diagonal, and there's a diagonal right there. Okay, notice that connects to that diagonal, and you have this one connecting right there. Now, two new words, convex and concave. You might see this in science class too, and you'll see it later on in calculus. Convex means that if I extend, simply put, the way I like to teach it is if I extend any side of the polygon, none of those will go inside the figure. Notice they stay outside the figure. That's convex. Versus, notice if I extend this one right here or this one right here, it goes inside, and that's concave. Okay, that's the way I teach it. The reason they brought up these diagonals is because in a concave one, you will have one diagonal at least that goes outside the shape, versus in a convex, the diagonals will stay inside the shape. So that's another way to remember it, okay, if that's easier for you to remember. So that's convex and concave. When we talk about the degrees of polygons and all this, we are only dealing with convex polygons. There's no rules for concave. Okay, the only time you're using concave is you're identifying it as concave. That's it. All of our polygon rules that we'll ever learn is dealing with convex polygons, just so you know. Okay. So that's we just talked about what you can conclude from that. Okay. Quadrilaterals formed using a circle. Okay. We're not going to draw this out right here. Okay, 218 is the next page. Go to 218. Okay. Nah. Go on. Concentric. Okay, concentric. Cone in Spanish means with, center, with the same center. So these are called concentric circles because they have the same center. And the main thing you need to know with concentric circles or any circles in general is that circles are always similar. So write that down in your vocab sheet. Circles are always similar. Okay, and if you remember, similar, when we talk about a similar shape, that usually comes from a dilation. So every circle is a dilation of another circle. all I have to do is move the centers together, and then I dilate one circle or the other to make it bigger or smaller, and I'll put it onto the other circle. Okay, so that's been a DCAS question. I've explained why circles are similar, and you just say that move the centers together, and you can dilate one to make it as big or small to map it onto the other. So that's the key thing you want to get with concentric circles. Okay, we're not doing any of this. Not doing any of this. All right, kite. Remember, we already have a kite on our quadrilateral hierarchy. Definition of kite is a quadrilateral with two pairs of equal adjacent sides. Okay, and they are consecutive sides. That's another word for adjacent. Okay. Then, as you already have in your quadrilateral hierarchy, it's got the characteristics. When the diagonals of a quadrilateral are perpendicular and only one bisects the other, it's a kite. Okay, so if we go down below kite, we have a rhombus. And then below that, we have a square. On a rhombus and a square, the diagonals bisect each other, both pairs of diagonals. Well, for a kite, only one pair does. So if I was to draw a kite, for example, like this, see only, if it's connected, only the longer diagonal bisects that shorter diagonal right there, and it's perpendicular. So the longer diagonal is called a perpendicular bisector of the shorter diagonal. Okay, so that's what that's referring to. The diagonals of a kite may or may not be congruent. Okay, usually never are congruent. Trapezoid. Here we have the right definition. Trapezoid quadrilateral with at least one pair of parallel sides, known as the bases. If the other pair of sides are not parallel, they're known as legs. Okay. A special type of trapezoid is an isosceles trapezoid. That's when the legs are congruent. This is my base, so there's my one pair of parallel sides. That's an isosceles trapezoid. When I have an isosceles trapezoid, just like an isosceles triangle, then the base angles are congruent. In this case, we have two bases, so both pairs of base angles are congruent. Okay, so you can fill that in there. If it's already on your, and look to see that those are filled in on your quadrilateral hierarchy sheet as well. Okay. Okay. Describe the diagonals of each quadrilateral. So you're going to use your quadrilateral hierarchy sheet to answer these questions right here. I'm not going to tell you. Use your quadrilateral hierarchy sheet and fill those in. So this, when it says the interior angles, it just means the angles. So what can you say about the angles of a parallelogram? Again, in a rectangle and a kite. Now we're just talking about the interior angles, the angles of themselves. So read on for your properties and list them right here. The reason I want you to list them here is because writing things out will help you memorize them. Remember, you got to get them memorized. Just looking at your quadrilateral hierarchy doesn't help you to memorize it. It helps some because you're using visual. Okay. Next, what you're going to do is you're going to use it. Try to do as many of these you can. I want you to go ahead and take a look at your quadrilateral hierarchy sheet. Go ahead and read through the entire quadrilateral hierarchy sheet for maybe 3 minutes. And pause the video, read through it for 3 minutes, and then come back and try to answer, put a check mark for each of these that is true without looking at your quadrilateral hierarchy. I want you to do as much as you can first time through without looking at your quadrilateral hierarchy. That's why I want you to study it, try to memorize as much as you can in 3 minutes. You can pause the video, then come back and fill it in off the top of your head, see what you got memorized now. And then after you've done all you can, then go ahead and look at the quadrilateral hierarchy and fill in the rest. Okay. These are, some of these are like this, would be on a DCAS where they say select all that apply. Okay, one of those types right there. So that's good right there. Here is determine whether it's true or false. We've already talked about these before, but definitions themselves, okay, such as A and E. or A and B, I meant. Now we're also talking about the diagonals of them as well. Okay. So we're going through, let's see, 229, A through F. Okay, so I want you to do this on A through F here. Okay. If you have to use your quarter hierarchy sheet, and we will stop right there. And then you've got a worksheet on inscribed quadrilaterals. Okay, so on that, let me do a quick refresher. It was at the end of that circles video you were supposed to watch. Okay, so let me just draw one here as an example. For those of you who did not watch the video or take notes. So remember, I have a circle, and then I have an inscribed quadrilateral. So just put a quadrilateral on the inside. Remember, if it's inscribed, each vertex has got to be on the circle. So that's an inscribed quadrilateral. Whereas this book is called a cyclic quadrilateral. Never seen that before in any book. It's not on the DCAS. They would call it inscribed. Okay, so as a reminder, let's call this A, B, C, and D. So you're going to get a worksheet dealing with the arcs, intercepted arcs here, and the inscribed angles. If this is 110 degrees, then this is 70. The opposite angles are supplementary, which obviously means two angles that add to 180. So that's 110, that has to be 70. If this is 120, then this would have to be 60. The opposite angles are supplementary. So they could give you a simple one with numbers in it, but on the DCAS, you know it's not going to give you that simple. It's going to put algebraic expressions there. So let's just say this now is, let's say, 2x plus 5, and this is 3x plus 10. Okay, so then I'm going to take those two, add them together. That gives me 5x plus 15 equals 180, because we know the opposite angle is supplementary. Subtract the 15 across. I get 165 divided by 5, and I get 33. So x is 33. So it asks us to solve for x. Your answer would be x is 33. If they wanted to solve for angle B, then I have to plug that 33 in there. 2 times 33 is 66 plus 5 is 71. And I can subtract 71 from 180, and the other would be 109. Okay. So that'd be another way for you to check that you solved it correctly. You can plug them in and make sure when you get the two angles, they add together to 180. Then you know you did it right. Okay, so that's one thing to remember with inscribed quadrilaterals is the opposite angles are supplementary. Now they could also, instead of doing that, they could go ahead and give you the arcs. Let's say they told you this was 70, and they told you this one was 140. Okay. Well, that means I could find angle D, because remember, that inscribed angle right there to right there, that arc is from there to there. And don't we have the total of that arc right there? 140 plus 70 is 210. And then I know an inscribed angle is half of it every time. So it'd be 105. So I'd put that at 105. Okay. And if they told me this was, say, 40, well, then I would have this one over here, because remember, this one, that to there makes that arc right there. That's 110 divided by 2 is 55. Got to make that 55. Now, don't forget, once I have one of those angles, I know I can get the opposite by them being supplementary. So if that's 105 there, then this has to be 75. So supplementary. If that's 105 there, this has to be 115 to add to 180. 125, man. 125 to add 180, which now means I can find this arc right here because this comes from this one and this one. And so that's 125. Then the whole amount from there to there has to be 250. Double that. And since that piece is 140, this must be 110 to give me the 250. Okay, so that's what you need to know when you're doing your inscribed quadrilaterals worksheet today. Okay, so we dealt with quadrilaterals in the section here, and now we're going to deal with inscribed ones on your worksheet because, again, this is on the DCAS. Knowing your intercepted arcs, knowing your inscribed quadrilaterals, guaranteed on the DCAS. Okay, so that will end that video.